project in finding a new Earth or another planet that can sustain life. So one of the main things that they use to find other planets outside of our solar system is the Kepler telescope. So this is the Kepler telescope, or a picture of it. And one of the main goals of the Kepler mission is to find planets outside of our solar system, especially ones that can support life. Yay! So one of the things that's so special about Kepler is that it can detect planets that are in the habitable zone, which is the orbital region around a star where a planet can have liquid water. And you need liquid water to be able to support life. So in our solar system, Earth is in the habitable zone because it has liquid water. So this green part's the habitable zone, and this is the star. So they nicknamed it the Goldilocks zone. Goldilocks zone, because if the planet is too close to its star in the red region, then the water evaporates. And if it's too far from its star in the blue region, then it freezes. So if it's in the habitable zone, then it's just right. And we get liquid water and possibly life. So Kepler detects planets using the transit method, which is as they pass in front of their stars. Okay. Using the transit method. So what it does is, as the planet passes in front of their stars, it causes a dip in the star's light, and they call it a transit. So say this is Kepler, and this is a star. So as the planet goes in front of Kepler and the star, it causes a transit. Transit. So when they see multiple transits in the same spot, they know it's a planet. Because if you just saw one, it could be anything going past, like an asteroid. Transit. And then they'd only see one. And it wouldn't repeat. So I did a graph. So this is the star, and that's its light intensity. So as the planet passes in front of the star, that's the planet, the light goes down. And it continues to go down. And as it leaves, it goes back up. And that's that dip in the star's light. And that's what they call a transit. So this is Kepler during construction. And it's basically a giant telescope mounted onto a spacecraft that flies it around space. So it's not on Earth, it's up in the sky, which is pretty cool. And its main instrument is a photometer. And it's a photometer. And that's how they tell whether it's in the habitable zone or not, because a photometer detects the light intensity or how hot or cool a star is. So the hotter a star is, the farther away the habitable zone is from the star. And the cooler the star, the closer the habitable zone is to the star. So, that's that. And then, Kepler costs $600 billion to design, construct, and launch, and operate, because they need people to sit at computers and look for transits, and look for the transits that occur. So, and it has a very wide field of view. 15 degrees across. Our moon takes up half a degree. So if you lined up 30 moons, you'd be able to fit 30 moons in its field of vision. This telescope has a 1 degree field of vision, so you'd only be able to fit 2 moons across its scope. So that's my project. Any questions?